A very good day to all of you. Today I'm going to present how to solve system of linear equations by Gauss elimination method using spreadsheet menu of Casio FX570EX Classwiz calculators. This is a spreadsheet menu and this is a more Casio Classwiz calculator that we use. For example, solve the system of linear equation below by using the Gauss elimination methods. For the solution, first step, we need to eliminate x1 from row 2. We need to make this one become 0. The purpose is actually we would like to eliminate the linear system here, the matrix A. If this is a matrix A, x equal to B, we are going to eliminate the A become the upper triangular matrix. Mean we want this lower part become 0 by using suitable row operation, which is negative A21 mean 5 divided by A11 which is 2, multiply row 1 plus row 2 and put into the new row 2. We can use a normal calculate menu, which is where the row 1 we can represent using variable A, this one, normal calculate mode like here. In the row 1 represent using the variable A. In scientific calculator here we can have 8 variables, which is red color A, B, C, D, E, F, X, Y, M, where we need to press a red color, press the alpha button. This is using the calculate menu, mean which one? Negative 5. Over 2 in alpha A plus alpha B. Then you calculate. Where the A is actually row 1, for this case you input 2, B which is 5. Once you get this value is 0. And then for second column, the A is 3, B is negative 1. Negative 8.5. Here. Then you calculate again for third column. A is 10, B is 1. Negative 22. Okay, for the vector B, first row A is 9, B is 6. Okay, negative 16.5. This is using the normal calculate menu. What we are going to solve today is using the new features of this model of calculator, which is we have a 5 vectors, 6 is statistic, 7 is distribution, number 8 the spreadsheets, similar to the Excel spreadsheets. However, it has limited column to 5 columns and 45 rows. On first step, we are going to input the original system into the spreadsheets. Okay, we check back the first row, the coefficient 2, 3, 10, 9. I think 2, 3, 10, 9. Second row 5, negative 1, 3, 6. Third row, 4, 7, 1, 2. Okay, correct. Okay, now we are going to input uh, the row operations of step 1 into the spreadsheet menu. Okay, and we put the result of the new row 2 into the row 4 in the spreadsheets. Which is the alpha equal. This is an assignment equal. So we have negative 5. So in the spreadsheet menu, we cannot see the natural display of fractions. So make sure we have the bracket, because since we cannot see the natural display of the fraction. And then row 1 in the column 1 is actually cell A1. So alpha A1. Okay, row 2 in column 1, which is stored in cell A2. So plus alpha A2. So you get 0. You see the formula. And then if normal calculate modes, you need to move to the column B, calculate, inputs your, okay, the row 1, row 2 value in column B, and column C, you calculate again, input the, okay, value for the row 1, row 2 in column C, and then, okay, for column D, you need to input the value for row 1 and row 2 in column D. That's the normal calculate modes. Okay, however, in spreadsheet, which has the ability to copy and paste, so we are going to copy the formula in cell A4, paste it to B4, C4, D4. So click the options, go down, number 2, copy and paste. Okay, we paste it to B4 to D4 by pressing equal. Then move to column C, equal, move to column D, equal. Okay, you can check. Okay? The result of row 4 is after eliminating the x1 from row 2. So you get this is 0, negative 8.5, negative 22, negative 16.5. Okay, then AC to clear the equal sign. Okay, later on, the second step is eliminate x1 from row 3. We are going to eliminate this one. Okay, x2, x1 from row 2 already eliminated, becomes 0. Now we are going to eliminate this, become 0, using suitable row operation, where the formula is negative A31 divided A11 multiply row 1 plus row 3 put into the new row 3. Where in Excel we are going to put into row number 5. So again, to assign a formula, you need alpha equal here. The formula is negative coefficient of row 3, 4, divided coefficient of row 1, which is 2, multiply row 1 in column 1, which is stored in A1, so alpha A1, plus row 3, this is stored in row 1, row 2, row 3. Sorry, I should make it bigger. Row 3, which is alpha A3. So negative 4 to A here in the spreadsheet will be A1, C, row 3, which is stored in cell A3. Then you press equal. Can go up to see the formula. Okay, in case you have key in wrong formula, what you need to do, just option, okay, edit cell. Okay, if not, you just AC. Now we are going to copy the formula of cell A5, paste it to B5, C5, and D5, similar to step 1 just now. So again, options, go down, copy and paste, move it to cell B5, paste it to cell C5, paste it to cell D5, then AC. Okay, you can check the solution with the normal calculation modes. Which is, okay, this is 0, and then 1, negative 19, negative 16. Okay, after two step, okay, we have reduced, okay, cell A11, A31 becomes 0. Okay, this is plus 1. Okay, and the third step, we are going to eliminate the cell coefficient of x2 from new row 3 becomes 0, so that we can get an upper triangular matrix, and hence we can use a backward substitution to solve for x3, later on x2 and x1. Okay, so to eliminate x2 from the new row 3 of step 2, against the row operation will be negative a32, mean negative 1 of, and then divided by, okay, cell A22, new A22. So which is negative of 1 divided negative 8.5. And put into the new row 3, where in X spreadsheet we put in row number 6. Okay, we move to A6. The formula is this one. A6. So alpha equal, so you have negative 1 divide negative 8.5. Okay, this is the new row 2, here. The new row 2, which is stored in cell A4. New row 2. So alpha A4 plus the new row 3, which is cell, sorry, this is not A. This one is B. Because here, because we are going to eliminate the cell B5 here becomes 0. So it's negative 1 divided by this one, multiply the new row 2, which is B4, plus the new row 3, which is B5. Then, okay, sorry, I make a mistake. Since this cell, alright, we are going to reduce the cell B5 here, becomes 0. So the cell A6 here should be 0. Okay, and then in the latest, okay, row 3 from row 5 here will be put it into row 6. So 0, it copy to 0. This one, we are going to reduce it become 0 using suitable row operation, which is negative 1 divided by negative 8.5. Okay, the new row 2, which is actually B4, the new row 3, B5. So alpha equal negative 1 divided negative 8.5 alpha B4 plus alpha B5. So you get it 0. Okay, and then we copy the formula from B6, paste it to C6 and D6. So to copy, options, go down, copy and paste, then move to C6 equal, move to D6 equal. Okay, you can check the solution with the normal calculate menu. Okay, where the result in the The result of step 3 is put into row 6. This is 0, 0, second column. The third column, negative 21.58. This is negative 17.94. Okay, you'll see how to get more than 2 decimal place. Can go to Shift menu, go down, Spreadsheets. Okay, choose number 2, show cell, show the value. Then can read here, negative 17.9412. This is negative 21.5882. Okay, hence, okay, how you get this one? The last, okay, upper triangular system mean there's no effect on the row 1. After the step 1, we reduce the cell A21 here becomes 0, where the result is row number 4. Okay, and step 3, the step 2, the result is reduce the cell A31 becomes 0, the result is A number 5. However, it's not yet upper triangular, we need to reduce the cell B5 here becomes 0. So this is a original first row. The latest second row is from row 4. Okay, the last row 3 is actually row number 6. Hence, we get this last system. And by using backward substitution, from the last row, negative 21.5882 x3 equal to negative 17.9412. Hence, okay, you may go back to the normal calculation menu. Means to solve the x3 will be, okay, negative and negative cancel, the x3 will be 17.9412 divided 21.5882. Where you get here, this is the x3. By plug in the x3 into equation 2, you can solve for x2. Lastly, plug in the x3, x2, then you can solve for x1 here. Okay, solve the x2 will be, okay, you have, will be like here. Negative 16.5, this one, plus 22 times the x3, which is here, 0.8311, okay, divided by coefficient of x2, which is negative 8.5. So you get negative 0.2099. Plug in x2, x3, you can solve for x1, okay, which is 9. So plus, move to the other side, minus 3 times the x2, which is negative 0.2099. Okay, plus 10x3, bring to the other side, become minus 10, multiply 0.8311. Okay, divided by coefficient for x1, which is 2. So you get the result 0.6594. Okay, or from the last system that you obtain, you may input into the equation modes. Here, you are going to solve simultaneous equation. Number 1, 3 unknowns. Then plug in 2, 3, plug in the coefficient row by row, 10, 9, 0, negative 8.5, negative 22, negative 16.5, then 0, 0, negative 21.5882, negative 17.9412, 0.9412. Then you can check, okay, before you third column corrects, second okay, then you press equal. So this is the X, this is the Y, this is a Z. Okay, mean by you, okay, after you obtain the upper triangular metric, is either you solve it using backward substitution manually using your calculator, or you can solve it using the equation menu in your calculator. Okay, of course, using the equations menu from this original system, you can plug in into the equation menu and directly obtain the solutions. But if the equation asks you to solve using Gauss elimination methods, you still need to go through the step 1, eliminate x1 here, eliminate this one, becomes 0, step 1, step 2, eliminate this one, becomes 0, step 3, eliminate this one to make upper triangular metric, and then using backward substitution. Okay, of course, you can check, okay, let's say we input the original system here. Okay, first row is same, second row, this is 5, and then -1, 3, 6, and this is 4, 7, 1, 2. So checking 3, -1, 7, 2, 5, 4. Okay, check with the last solution. Two zero nine eight, run a bit, one digit, 8311. So mean in conclusions, to solve the system of linear equation using your scientific calculator, actually you can directly using the equations menu, simultaneous equations, and can obtain the solution of your x1, x2, x3 directly. But if the question want you to solve Gauss elimination methods, okay, you have to reduce, step 1, reduce the x1 from row 2 becomes 0. Step 2, reduce the x1 from row 3 becomes 0. Later on, reduce the x2 from the latest row 3 becomes 0 to obtain upper triangular metric, and then you use backward substitution. Then you may calculate it, mean the step 1 using the calculate menu, or you can use the spreadsheet menu in your scientific calculator. Okay, with this, thank you for your attention.